Of inequalities. So what was lesson 6-1 about? Graphing systems of linear equations. So what's the big difference? The types of signs. And that really is the big difference, because this will affect what my solutions are going to be. Okay, on these problems, the first thing you want to do is get it into slope-intercept form. Both of them into slope-intercept form. How many of you like graphing from slope-intercept form? Like, you rather do it there than standard or point slope? Okay, that's common throughout the years and throughout schools and grades and all that. So how do I get the first inequality, x plus y is greater than 10, to be in slope-intercept form? What do I do? Subtract x from both sides. And if you want to make it proper, you're going to get y is greater than negative x plus 10. That's your slope-intercept form. For the first one, I'm going to circle that because we're going to have a lot of work and I wanted to see it clearly. Okay, how do I get the second equation into slope-intercept form? Subtract x again in this one. And you're going to be left with 3y is less than or equal to negative x plus 24. But I still have that 3 on both sides. So divide 3. And really you're dividing everything by 3. And you're going to be left with y is less than or equal to what? Negative 1/3 x, negative 1/3 x plus 8. Negative 1/3 x plus 8. Those are your two inequalities. Okay, now they're graphable, or I should say easily graphable. Go ahead and create your coordinate plane. And we're going to graph these two and see how we get our solutions from this problem. So here are my inequalities, and I'm going to draw my coordinate plane. And should I go by 1s, 2s, 7s, or 10s?
2.
I think 2s might be good. You can go by 1s, but then your graph gets tall. I'm going to go by 2s. But there is a problem with going by 2s that we'll have to address. Bless you. Basically, you can go by any denomination, but you can make your life easier by going by certain ones and certain problems. Okay, let's just graph the first line. And I'm ignoring the greater than sign. I'm just thinking y equals negative 1x plus 10. So where would I start the first graph? Do you guys know? 10 on the y-axis. So I'm going to go by 2s. I'm going to go 2, this is 2, this is negative 2. Let's take it 2. Everything by 2s. 2, 4, 6, 8, 10. And then where do I go from there? Well, what's my slope?
Down 1 over 1.
Okay, you can go down 1 over 1. Can you go down 2 over 2?
Yes.
Why? Yeah, because down 1 over 1, that's negative 1. Down 2 over 2, that's negative 1. So we're going to go like that. So I can go one tick each time. Or I can go up 1 over 1 to the left. Okay, now notice all I have is dots. All I have are dots here. Because when we're graphing inequalities, we have to consider, are we having a dashed line or a solid line? Do you guys remember that from last year? Solid line or dashed line? Does anyone remember? Dashed line. And somebody tell me why it's dashed.
Because it's not.
There's no equal to sign there. Do you guys remember your line graphs where you had like 3? Do you remember when it was open and when it was closed? When is it an open circle? When there's no equal to sign. When is it a closed circle? When there is an equal. It's the same thing there. So we're going to call this an open line, and it's dashed. And then draw your little arrowheads because they go. That line split the whole coordinate plane, all those infinite numbers, in, what do you think? Half. Straight in half. Because how many numbers are over here? Infinite. How many numbers are over here? And there's really an infinite number on both sides, an equal amount of infinite numbers on both sides, which is weird to think of, but that's what you call it.
I did down 2 over 1 or over 2.
Yeah, you can do down 2 over 2.
But it looks different.
So remember, these are all 2, so down 1, 2 over 1, 2. And then down 1, 2. So it should be that. Okay, let's look at the second one. Where do I start the second one? Michael? Second graph. Positive 8 on the 2, 4, 6, 8. So right here, that's the second one. And then where do I go from there? What's my slope, Jensen?
Down over 3 or down 2.
Okay, so I'm going to go, yes, down 1 over 3. That's a little tricky. But what if I go down 2 over 6? Is that allowed? Why? What's 2 over 6? 1 over 3. So I can go down 2 over 6. Or if you're like, I didn't like that. Down 1 over 3 would be right here. Down 1 over 3 over there. So it'd still come out. Or I can go up 2 over 6. Okay, and what kind of line is that one? Why solid? Because it has the equal to sign. So I'm going to do this for you guys to help you out. Dashed. Solid. And you got to remember that because that's part of your answer. But my graph is not done. I just have lines, but I don't have the solution. Okay. Yes, ma'am? Did you go down 1 over 3?
Did you go over too far?
It's going. Well, we went down 2 over 6. So down 2, 2, 4, 6. So we can still do that. Or up 2 over 6. Okay, here's what you want to do. Do you guys remember what's missing in this graph, Betsy? The lines look good, but what's missing? You have to do what? You have to shade something in. I haven't shaded anything in yet, right? Please pay attention so I can help you out here. Look at this first one. Rachel, this is a greater than symbol. This is the line. What region is greater than this line? Anything that is above it. So this region would all be greater than the first line. Would you agree? You guys agree with that? Okay. That's the first line. What region is less than or equal to the solid line? Anything that's below this line right here. And I know this gets messy, but we're going to clean it up. Anything below that line, right? What region did I shade twice? You can darken it, or if you want to do a pen. And I'm going to make it better on the next ones because I don't want to keep shading everything. That makes it really confusing. But this region right here was shaded twice. Okay, here's the explanation. Like, why did I shade everything and then finally shaded that red? Do you guys remember if these were equal signs? How many solutions are in the top equation? Infinite. How many solutions are in the bottom equation? Infinite. How many solutions would fit both at the same time? Usually 1, right? And that's what we had on our quiz, by the way. 1. So I'm asking what would fit both of these inequalities? Well, what region fits both of these? It's right here.
But it's still like an infinite number.
It's still an infinite number. And that's why I can't give you you're not just going to give me one ordered pair. You're going to give me a shaded region because how many ordered pairs are in here? By the way, it keeps going. Infinite number. Do I want you to give me all the infinite number of ordered pairs? Please don't. But you can't give me that. Now, I'm a little confused because I think that's not right or I don't get it. How many points are in here? Infinite. Pick any point in this region and let's see what we can do with it. Can anyone pick a point in here? I know it's a little... 12. 12 is like here, 3? Okay, would that be in this region? I think so. I think so. Hold on. 2, 4, 6, 8, 10, 12, 3. Okay, I'll go with that. 12, 3. Okay, Shouldn't 12, 3 fit into both of these? So let's see here. That's 3, and that's 12. Is 3 greater than negative 2?
Yes.
It checks, right? That point checks. And then this is 3, and that's 12. Okay, what's negative 1/3 times 12? Negative 4. What's negative 4 plus 8?
4.
Is 3 less than or equal to 4? Yes. Does that point over here work in both of them at the same time? Yes. Can anyone give me a point that will not work in both of them?
2, 2.
Something that's very friendly and nice for us. Murphy, do you have a question or a point? Point, give it. 212. Should 212 work? 2, 4, 6, 8, 10. Oh, you're right. Thank you. Right up here somewhere. Wherever I wrote. I'm going to do this. Erase that.
Yeah, makes it pink. Put on it.
It's my favorite color.
That?
Whoa,
It has like a blue outline.
Oh, yeah, because of that erasing. Okay, 212.
Got one.
All right. 12 is greater than negative 2 plus 10. All right. Is 12 greater than 8? Check. What's negative 1/3 times 2? Negative 2/3. What's negative 2/3 plus 8? 7 1/3. All right, good. Is 12 less than or equal to 7 1/3? No. Why did it check on one but not the other? Do you guys know why it checked on one but not the other? Because oh man, I wish it would have checked. It checked up there. Jensen?
That's because it's in the shade line over there, which is on the top problem.
Yes, the top inequality, it works, and it did. But the bottom inequality, it doesn't work. So what points fit both of them? Anything that's in here. So can you check? Yeah, and the nice check I usually do is I pick one number in there to see if it works, and then I tend to use 0, 0 because that's easy to work out.
Good.
It could, yes, and by the way, any of these could be wrong because you graphed it wrong and you messed it up.
No, as opposed to be 1.
That's even better. I like that thought. Yep, you're right. Yes, ma'am?
So for these problems, you don't have to list like where it intersects or anything, do you?
No, you just have to graph that. Like that's your answer, the red part. Okay, let's do another one. And I'll show you how you can make it cleaner because there's a lot of scribbling there, by the way.
Are we going to use a pen on our homework or something to show that or something?
No, we're just going to shade the correct region.
Oh.
So we're not going to shade everything anymore. Yes, sir?
I know the problems.
Yeah. Okay, so the first thing I need to do is I need to make these in slope-intercept form, right? Is the top equation in slope-intercept form?
No.
No. So I need to get it there. Marissa, how do I get it there?
You subtract the x on the side.
So I'll get y is less than or equal to negative x plus 3. Okay, so I'm going to circle again just to reference easily. How do I get the second inequality to be y equals mx plus b? Question.
I remember that when we did these, we had to like flip the sign. What did we flip the sign?
When we divide by negative.
Yes. Okay, good. Both of you got it. So there are times where I have to flip that sign, but that's if I multiply or divide both sides by a negative, which we will get to because we do need to review that right now. Okay. Alyssa, how do I solve for the bottom y?
You subtract 2x.
Okay, first I'll subtract 2x from both sides. Negative y is less than negative 2x plus 3. Okay, do I want negative y? No, I want positive y. So how do I get it to be positive y? Okay, we're going to do it this way because what happens is, did I divide both sides by a negative?
Yes.
Mm-hmm. So I get y, and I get 2x, and I get negative 3. But what happened to that lesson symbol? It became greater than. It must become greater than because of that dividing or multiplying by a negative. Do you guys remember that from inequalities? So all these rules still apply for this. And you're like, Miss Ray, what if you didn't do that and you graph it Wouldn't it work? It might work for one of them, but will it work for both of them? No. So, you get one of those solutions in that partially shaded region. All right, let's go ahead and graph. Should I go by 1s, 2s, 4s? I go by 1s. 1, 2. All right, Caroline, the first line. How would you start that one?
We start at 3 on the y-axis, and then go -1 up, or subtract 1 up.
So down 1 over 1. Yep.
Oh,
Okay, and then down 1 over 1.
yeah.
Or you can go up 1 over 1.
Mm-hmm.
Okay, and what kind of line will that be? Solid or dashed? Solid. Why, Caroline?
Because it's greater than or equal to, has equal sign.
Good, the equal to sign, so that's solid. Very good. Okay, and then let's graph the second line. Rachel, how do I start that second line right here?
-3 on the y-axis.
Okay, -3 on the y-axis, and then where do I go from there?
Up 2 over 1.
1, 2 over 1, 1, 2 over 1, 1, 2. Okay, and what kind of line should that be? Solid or dashed?
Dash.
By the way, they're not always one is solid, one is dashed. They can both be dashed, they can both be solid. What determines that? Whether it has an equal to sign or not. And so different problems have that. Okay, Nick, let's look at the first line here. What region would be less than the solid line?
Wait, less than is under, right?
Yeah, less than is. So it would be, notice I'm not marking anything, right? It would be all this region, right? Everyone okay with that? Be all this region right here? Okay, so we have that mentally there. What region would be greater than the dashed line? So it's above it. So that would be everything over here. Don't say anything yet. So is it region A, which is this region, region B, which is this region, region C, which is that region, or region D, which is that region? I heard 5 of you maybe?
Well, I'm confused what you're asking.
Yeah, what should I shade? What should I shade? This part, this part, this part, or this part? Multiple choice. Okay. Remember this first line, I'm going to go over it one more time and make sure we pick it up. So this one is less than or equal to the solid line, right? So wouldn't A and D be shaded for the first inequality? Yes. For the second inequality, it's greater than the dashed line. So it's greater than the dashed line. So wouldn't A and B be shaded? Yep. Which region was shaded twice? A. Yeah, A. A is shaded. So that's your shaded region. Is that the solution, though? Really? Pick a point. Pick a point.
Wait, so what do you want this like? What's like?
This is your answer right here. And you don't even have to put the letters. That's there for.
So for homework, we just have to find the thing, and then if you want us to check it,
Then you put a point. See which ones are. So listen, that's a good question. This right here is your answer. Like this is what I'm grading right here. And then you, if you're working out, you're like, why don't you pick a point to check it? So Davis, what would you pick to check?
0, 0.
Shouldn't this point right here work? Okay, so you check it. So let's put it right here. Well, actually, we can put it right here. What's 0 plus 0? Is 0 less than or equal to 3?
It is.
Yes, it checks. What's 2 times 0? 0 minus 0. Is 0 minus 0 less than 3?
Yes.
Checks again. What point should not work? What should not work?
0.
Yes, ma'am?
3.
1, 2, 3. 1, 2, 3. Yeah, so something up here. I think it's something right here, right? Okay. Okay. Should it work for either one?
Not for both.
Okay, not for both. Good. It's definitely not for both. But let's see if it's either one. Sorry, I'm trying to see where my work was. All right. So we said 3, 3, right?
Yes.
Okay. Sorry, I just want to make it clear. All right, 3 plus 3 is less than or equal to 3. Is that true? False. What's 2 times 3? 6 minus 3 is less than 3. Oh!
No.
Is 3 less than 3?
No.
No. Now, do you guys notice something here? Wasn't this point on the line? But it's dotted, so that means this point itself does not fit into either one. And in this case, we could prove it. You guys see how that works with the dash solid? There's a point to that.
There's a point.
These just happen. I'm just naturally coming up with these things. All right, your turn. Graph these. Did we do these already? We did this already. This one, I'm so sorry.
No,
The other one we already did. I'm sorry. I had a different screen for that. So graph these on a number line, and don't shade anything. Don't try to shade in yet. I just want you to practice graphing. What kind of lines must these be? Okay, good. They must be dashed or dotted, and they must be parallel. Okay, why are they dashed?
Because they're special.
There's no equal to sign. Why are they parallel?
Because they have the same slope.
Same slope and different y-intercepts. What happens if they had the same slope and the same y-intercept?
Then they're the same line.
They'd be the same line. And you're not going to get too many of those, but you can still figure out that solution.
It's a peach. Smell it. It smells like peachy.
I can't smell, so.
Oh, okay.
I imagine the smell of peaches. I do, a lot.
Cobblers the best.
And nectarines, which are peaches.
Oh, I love this.
Wait, they are? What's the difference in them?
I don't know. I think it's just like, what was I trying to think?
The peach tree farmer does something too.
Yeah, he injects growth hormone into it, and it makes it bigger and stronger. And literally, that's what you can do to fruit. And less natural. But tastier.
Yeah, I love nectarines.
Yeah. No, there is a difference. I don't know what it is, but they're pretty much the same. Okay.
One's from the orange family. They're in-laws.
Okay, 1, 2.
Everybody draw Frosty the Snowman's hat. His black hat on your page.
All right, where would I start the first graph, Betsy? First graph.
On the positive
On the
y-axis,
y-axis. All right, where do I go from there?
you go down. You go down 3 over 2.
1, 2, 3, 1, 2. All right. Or you can go up 1, 2, 3, up 2. So something like that. What kind of line is that one going to be, Mackenzie?
It's going to be a dotted line.
No, this is what I do if you did it in pen, and hopefully you didn't get a pencil. So let's say you did this. I do this. So that makes me... Okay, the second line, Emma Grace, where do I start the second one? On the y-axis, and then where do I go from there?
Down 3 over 2.
It's a snowman.
Mr. What would happen if you were to graph both of them on the x? Like, instead of, if you do the same problem, instead of putting it on the y-axis, put it on the x-axis.
Oh.
So put like closer to...
So you switch it around.
Yeah, you just swap it.
So this is where like you swap those two, you get x's and then y here. Or you just graph it wrong. Like, or you mean you just graph it wrong, or you actually switch it mathematically around? Because there's a difference.
Yeah.
Okay, I'll go with you just started on the y or the x-axis, then you went. See, then you went.
Just to one of them. You took both of them. You do everything the same on both of them.
Yeah, you just switch it off. Things do not come out the way we want it. Like, not only the wrong answer, I think I would even just try it out because I want to see it visually. But your slopes are all messed up, and then I don't even know what your slope is because you have to look at the other variable. So I've thought of that, but not too much.
What should we do? That's what you said mathematically when you switch it. Would you, for the slope, would you you switch those?
I think you'd have to, and then you get something else.
How many snowballs is Olaf made out of?
What region are we going to shade? So let's look at it here. What region is greater than this line? It's anything above it. So, okay, we're imagining this. What region is above the second line? Anything above it, right? Imagine this. It'd be anything, above it. Which region is shaded twice?
The one in the
Above
middle.
the dotted line.
Above this line right here.
Wow.
Because,
Well,
what about this part?
Yeah.
So this point, 0, 0, it's going to work for one of them, but not both of them. And that's the thing. You want to shade what region got shaded twice. So remember, I shaded this first, and then I shaded this second. And so what region got shaded twice? Only this part did. And that's a tricky one. That's why I gave it to you. Okay, ready for this one? This one no, this is your graph. This is your answer. And to check it, you could do order pairs. So you start picking order pairs. All right, this is what I want to do with this one now. All right, I'm going to change some things up. And you don't have to do this on your paper, but because it's on the bottom of page 163. But let me go with this one. Okay, let's just look at the same lines. But you notice I switched those inequalities. All right, look at the first inequality. What's greater than the top line? We already know that, right? It's anything above it, right? What's less than the bottom line? Anything below it. Which region was shaded twice? Neither. What's my answer? No solution. There is no number that fits both of them at the same time. Because is there any number that's great? Think about it. Is there any number greater than 10 and less than 10 at the same time?
Yes. A number that was born on leap year.
No, it still wouldn't work. But that's the whole idea. You can't be greater than this line and less than that line at the same time. That's what we call mutually exclusive, which is very cool. It's a good logical concept. Sorry? Nope, no imaginary number fits either. This one right here is your next graph. Honestly, when we say imaginary numbers, all numbers are imaginary because they're all in our head. We just write symbols to represent them. But technical imaginary numbers are numbers like I.
Mind blown.
Yes. You use imaginary numbers all the time. Some of you want some extra, and I don't mind giving that.
But that means you have to do that.
Yep. And I don't mind that.
You're an imaginary number.
Graph that.
You never answered the question.
He's avoiding it.
Oh my. You know what I should do with Swivel? I should turn him around.
Oh, no.
Film you guys, send it to your parents, and let's see what they would say.
You're drawing a really good snowman right now.
They probably posted it on Facebook or something.
Some of you would be missing a device. You would be not going to certain places. I think a lot of things, but not all of it. Some of you would be fine. Your parents would be proud. They'd be like, what? They actually pay attention? They actually answer questions? And then some are like, where are they? I can tell they're not even there. But that's a Christmas present, not for now. That would be interesting. Sorry, Swivel. You're going to have to record that one. Okay, the first line, is it in slope-intercept form?
No. Yes. Yes, it is. It is.
Oh. Okay. Then graph it. Where do you start the graph, Nick? The first line.
The graph?
Mm-hmm.
Well, the first one, sorry, it's 0. I just
Oh, is there a plus 0 right here? Okay.
No.
There is.
I don't see it.
Okay, so the plus 0, I'll start there. And then where do I go from there, Nick? Up 3 over 1. 1, 2, 3 over 1. Down 3 over 1. Good. What kind of line? Yeah, solid. That's okay. Don't get too excited about it. Do you say sorry a lot? I do too, Dave. That's why I say sorry a lot. Like I'm walking through and someone trips over something. Not mine. I didn't know. And I say, sorry about that. I feel bad because I'm sorry. But sometimes I get too much into the habit. Did you get that right? Oh, sorry. Like that. Sorry. I didn't mean to bring that up. I'm so sorry. And I remember my first job. My first job was KFC. Yeah. It was a great job because I could walk to KFC. I wanted to work since I was 15 when I got my first job. Summer. And there's this guy, he was like the guy who was like training me, and he would say sorry he would go, sorry. And I just remember he said sorry too many times. At least I don't say it that many times. But yeah.
Sorry.
With KFC, sorry, I'm going to have to say something here about KFC. So I would fill in the 20-piece bucket. And then 1 week I came in. And the pieces were double in size. Like doubled. So I couldn't fit the chicken into the one bucket. I had to use 2 buckets. Slamming that wing in there. Shoving it. Because they were huge. I'm not kidding. I remember saying, Dad, why are they so big? And that was a discussion. And sorry, Dad. Yeah, when he would pick it up, I would say, Dad, why are they so big? They're trying to make money. I'm like, oh, cool. So you just make things bigger. But yeah, growth. No, I just asked them. I didn't ask the people there. I was afraid of the answer.
Was it even real chicken?
What's your definition of real? It was really there. It's there. Eat it. That was fun. That was a fun job.
Yeah, Mr. Ray, was it actually chicken?
Is VIP access all free KFC?
Yeah. What I would do, I'm done after this. They gave us free lunch, so I would. In the summers, you can work a little longer because I was so bored in the summer. I wanted a job. I just got, yeah. And there's more stories with that. So I would get chicken strips, mashed potatoes, baked beans, mac and cheese, wedges, and the drink, and I would eat that all up. I had this whole plate full, and my boss would always look at me and say like, he'd just kind of look at me because I'm taking too much food, and there's just a pile of food, and it was cornbread, can't forget it.
Their mac and cheese is good.
Sorry about that.
I never even been.
No, I was so young, guys, it didn't affect me. In fact, I think about the things I ate at your age, middle school, high school. Man, I cannot do that anymore. If I try to eat what I ate there, I would be hurting, in pain, suffering. Yeah, so it would have been even worse.
No more KFC.
Yeah, no more KFC. Huh? No, you guys, you can eat a little bit more, and that's okay. But wait, because it won't be like that forever. That's okay. That's how you make money. All right. Let's look right here. And Murphy, how would I start this one? Is this what you got, by the way? Y is less than or equal to me. Okay.
You do -2.
On the Y, and then?
Go down 1 over 1.
Or you can go up 1 over 1 right here, or up 1 over 1. And what kind of line? Okay, so do you always get one solid, one dashed? No. You sometimes get both dashed or both solid, like we do here. Okay. What region should be shaded? Does someone have a region shaded? Don't say it. Just tell me you have a region shaded. Go ahead and shade a region if you have it.
Can you
need
letter
to
them
shade
again?
it. Sorry?
Can you letter them again?
Letter them? Yes, I can.
No.
A, yes, B, C, and D. And again, A is this whole region right here. D, C, and B. So we'll do a vote, and we'll do it blind. How many of you are still working? Anyone? Okay, good. Close your eyes, put your heads down. All right. I'll give you some time. All right, you can open up your eyes real quick. Sorry, we still need someone to do it.
Okay, I'm ready.
All right, put your heads down, close your eyes. No peeking. I want to see who got the right reason. So your choices are A, B, C, D. So pick the one, whichever one it is. All right, pick the one you want. Pick the one. Sorry, just pick, and then maybe you'll get it right. Maybe you won't. Pick. And then once you got it, close your eyes, put your head down. Okay. Who picked region B? All right, put your hands down. Who picked region C? All right, put your hands down. Who picked region D? Okay, put your hands down. And who picked region A? All right, put your hands down. Okay, lift up your heads, open your eyes. Okay, it was equally split. 4, 4, 4, and like 3, or maybe there's like a 3 or 5. We had equal amount of votes about for everyone. Some of you are wrong. A few of you are right. Let's see which one it is. What would be greater than this line right here? What would be greater than this line? It'd be D or C. So D and C are our only options so far. What would be less than this line? It would only be C and B, which gives me C as the solution.
I got that right. I just wanted to start with.
I didn't, and I would have taken it. Oh, it does make. Okay, and I'm telling. No. Hold on. Time out. I really want you to get in this because I want to say the same thing. If it doesn't seem clear, say it doesn't make sense to me. Because it does make sense, but it doesn't always make sense to me. So what's your question?
Well, just like I got that.
Awesome.
Wait.
Oh, wait, huh?
Sorry.
Now it doesn't make sense.
No, it does.
It does, it doesn't, huh? Let me let you figure it out. I'll get Murphy and then ask the question. Yes, ma'am?
So, I didn't realize that if it's like greater than or less than, less means you're under it.
Yes. Greater than means over or above it, and less than means under it.
So if it was greater than you would be D?
If it were greater than this one?
Yeah, if it was greater than it would be D.
This was this line right here. If it were greater than, I think it was D. Yeah, because, it would have been greater than both D. Yeah. Yep. Yes, ma'am?
For the y is greater than or equal to 3x.
Yep. That's this line right here, right?
Yeah. Why would it be to the left?
So this is what I did last year. I'm going to do it again. So that's, make sure that's this line right here, right? This is the line. What region is above this line? Anything above it. So that's the tricky part. All right, guys, we're going to play this game again like we did last year. I'm going to give you a line, and you're going to tell me what part, this part or this part, is greater than. All right, ready?
Mr. A is twirling.
Right.
This side is greater than, all right?
Left. Right.
Left.
Perfectly vertical. Yeah, anything to the right is going to be greater than. Like a vertical line, you will get.
Top.
Okay, ready? Less than now. Ready? So you guys switch your minds again. I can do this. Look at this. Less than.
Swivel, then you get that.
Phil didn't get it because it was so quick. It was just like a helicopter spin. All right. Less than.
Left.
Okay, so that's the kind of thinking you're doing with those lines. Oh, perfect. Goodbye, Swivel. Okay, goodbye, Swivel.